As we learned, Bitcoin is cryptocurrency based on the decentralized trustless verification system. But how is it possible? If no one trusts no one, how does the system work at the first place? How do we make sure no one messes with the system, for example adding a fake line to the ledger saying Iman paid Mitch $200 or even overspend money? To achieve a system that is trustless and fraud-proof, we need cryptography. So the Bitcoin philosophy is basically nothing more than a public ledger minus trust plus cryptography. That's why Bitcoin is called cryptocurrency. To understand the underlying principles, first we need to learn about digital signature. Digital signature has two main components: public key, which is like your email address that you share with other people, and private key or secret key, which is like your password. To send money to someone, you just need their public address. A simple analogy for this is you just need someone's email address to send a message to them. But to initiate the transaction, you need to use your private key to sign it. This is similar to the case if you want to send an email from your account to someone. First, you need to log into your account using your password. In other words, you need to get verified using your password or your secret key. Now let's fully digest how the Bitcoin works. The smallest unit of Bitcoin system is one transaction. Imagine I want to send 2 Bitcoins to Mitch. Bitcoin is exactly like any valid currency like dollars. This is the simple message: Iman pays 2 Bitcoins to Mitch. The problem with this message is it's too transparent to the public. We don't want that. To protect the identities, we replace names with encrypted strings. How we encrypted this is beyond the scope of this video, but to let you know, these values are derived from your public key and are unique to you. It's very difficult to link these strings to the actual person, but if you are in law enforcement or very well informed, it's not impossible. For this reason, Bitcoin transactions are considered pseudo-anonymous, not fully anonymous. The next step to have a valid transaction is to sign it by the sender. The math behind it is a bit complicated and rely on an algorithm called SHA-256. Here is a simple explanation. To sign a transaction, the sender combines the message with the private key and then pass it through the algorithm SHA-256. The output is a signature with a fixed length, 256 bits to be exact. The thing that makes this algorithm super cool is the fact that it's not reversible function. What does it mean? Let's say we have this function y equal to 2x. If I tell you x is 3, you know y must be 6. Or if I tell you y is 6, you know x must have been 3. So this operation is reversible. If you have x, you can find y, or the other way around. But SHA-256 is not reversible, i.e., if you know the signature and message, you cannot find the private key. You can of course guess it, but the chance of finding the correct private key is 1 over 2 to the power of 256. This is stupidly a large number. To put it in a perspective, 2 power 32 is roughly 4 billions guess. So 2 to the power of 256 is this multiplied by itself by 8 times. So this translates to roughly 65,000 billion guesses. So good luck finding it. You might say, okay Iman, I get it. It's impossible to find the private key from the signature. But why the hell I need your private key? All I need is your signature to forge it. And you say, if the digital signature is basically a bunch of zeros and ones, what prevents me to copy and paste it wherever I want? You're smart, but you wish that were true. Please note the output depends on both the message and the private key. Unlike the handwritten signature that looks exactly the same on all documents, the digital signature will change as the message changes. To understand this, let me run a simple example. Let's say This is our message. I combine that with my private key, and here is what I got if I apply the magic SHA-256 function. Now, if I change the message slightly just by adding a dot at the end with the same private key, I'm gonna get something that is completely different. That's the beauty of digital signature that we use to sign our transaction.